Hello guys, welcome back to my channel Maths for All by Saurav. So till now we have completed 4 chapters. In our last video we have completed the practice set of quadratic equation. Now let's come to the chapter 5 arithmetic progression. So we are covering, so this is our agenda. So we will be covering what is an AP, what are the properties of AP, how AP is going to solve the real world problems, how to calculate the nth term in the AP, what is the significance of the last term, and some of the n terms. Okay, so let's start. So we have an AP series here. Okay, we need to find whether this series contain minus 81 and what is the number of that term, and is this AP also contain 0. Okay, now let's identify. For example, which term is minus 81? Okay, we don't know the n value here. So nth an term, which is minus 81, we can say a plus n minus 1 into d, right? Minus 81, a is, we know, right, 21, first term. Okay, and the difference you can say d is the difference here. Okay, n minus 1, and we can't know, so d we can put, this difference is 18 minus 21 will be minus 3, 15 minus 18 will be minus 3, so you need to put minus 3 here. Now solve it further. Minus 81 is equal to 21 plus minus 3n plus 3, and you will be get minus 81 minus 21 minus 3 is equal to minus 3n, and if you take minus 1 common, you need to add all these three number, you will be get 105. Okay, now is equal to minus 3n, minus minus cancel, you will be get 105 upon 3. So 35. So n is equal to 35, which implies that a 35th term will be minus 81. Okay, now we find first solution. Now now we need to verify whether 0 is contained in this series. Okay, now suppose the 0 is there with some n term. Okay, let's say a n, which is 0. Okay, now is equal to a plus n minus 1 into d is minus 3. Okay, a we know, which is 21, n minus 1 minus 3, and it is 0, so we can take it as 0 is equal to 21 minus 3n plus 3. Okay, now take 21 plus 3, 24 is equal to 3n, n is equal to 24 upon 3, which is 8. So a 8th term will be 0. Okay, so we get first the minus 81 term, we get is the 35th term in this series, which is minus 81, and a8 is 0. You can see, right, this is a decreasing series, so sometime it will come 0 here, and then again negative minus 81 here. So this is our 35th term, and here is 8th term, 0. Okay guys, now come to the next example. So here we need to find the AP. Okay, we know the sum term, or maybe we know the third term, seventh term, and on this basis we need to identify the complete AP. Okay, now you guys, this is third term. Okay, for the nth term formula we know an is equal to a plus n minus 1 d, where a is the first term, d is the common difference, and n is the nth term. Okay, nth term we can calculate by this formula. So we know a3 will be a plus 3 minus 1 into d. We don't know, and d is also we don't know. So let's see, a3 is 5. Okay, a plus 2d. Okay, one equation we get this one. Now solve for a7, which is equal to 9, is equal to a plus n minus 1, which is 7 minus 1 into d. 9 is equal to a plus 6d. Okay, now we have two variables, two equations, and we can easily solve it. Okay, now do one thing, difference equation 2 minus equation 1. Okay, do this thing, 9 minus 5, you will be get 4, a plus the a minus a will be get cancel, 6d minus 2d, you will be get 4 is equal to 4d, which implies that d is equal to 1. If you put the value of the d here, now if, for example, 5 is equal to a plus 2d, 5 is equal to a plus 2, a is equal to 3. Okay, we know the first term and the common difference. Now we can identify the AP, right? So first term is 3, AP is 3, the difference is 1, 3, 4, 5, 6, 7 and so on. So this is our AP with the initial value is A, first term, and the common difference D is 1. So we need to just add plus 1, right? Like that. Okay guys, now come to the next example, example 6. Here we have a series, AP series, and there is some term 301. We need to verify whether this term belongs to this AP or not. Okay, so how we proceed this in this one? So we don't know the first and common difference. Okay, first calculate the first and common difference. For A is 5, D is, this is AP, right? So the difference is 4. 11 minus 5 is equal to 6. Okay, you can see here is 6. Okay, we know that A and D here. Okay, now we need to find whether this 301 belongs to this one. For example, this number belongs to this series for some nth term. Okay, for example, some nth term here. Okay, now for nth term formula we have A plus n minus 1 into D. So A n term value is 301, first value is 5 plus n minus 1. Okay, n minus 1 into D. D is 6. So we need to find at which term this belongs, if it is exist. Okay, so solve it further. You will be get 5 plus 6n minus 6. You will be get 301. This will be minus 1. Here it will come plus 1 is equal to 6n. Now it will be 302 upon 6n, and it will be 151 upon 3. Okay, now see, this is not an integer. Implies that n is not a integer or a positive integer. Is not a positive integer, not even an integer. Okay, so hence this number, but here n is some integer value, right? It's some place in that series, right? So it is not exist in this one. So 30, our solution is 301 not exist in above AP. Okay, it will not exist in this AP. Okay guys, now come to the next example. Okay, in this we need to find how many 2-digit numbers which are divisible by 3. Okay, divisible by 3. The first number which is divisible by 3 2-digit number is 12, right? Now it will be 15 and it will be like that until it is 99. So we need to find how many such numbers are there. Okay, so A is 12, D is, you can see, 3 because it is a divisible by 3. Okay, so now nth term we know A n is equal to 99. So if we find this n value, then we will find the how many numbers are there in this series. Okay, the an we know is 99. 99 is equal to A plus n minus 1 into D. Okay, 99 and A we know is 12 plus n minus 1 into 3. Solve it further. You will be get 12 minus 3, which is 9. 99 minus 9 will be 90 upon 3, and is this one, which is 30. Implies that n is equal to 30. So 30 numbers are there in this AP which are divisible by 3. 2-digit number which are divisible by 3 are count is 30. Solution. Okay guys, now let's understand more examples on this AP. So in the example 8, we need to find the 11th term from the last. Okay, now here you guys see, first term is 10. Okay, and the last term is minus 62. Okay, and we don't know the actually count, so to count of the numbers in this series. So first we find the D. D is, you can see, minus 3. Okay, D is minus 3. Okay, we need to find the 11th number from the last. Okay, so there are two approaches. First we find the count number of the find the total numbers in this one, in this series. Okay, for example, there are some n numbers. Okay, and then we need from the last n minus 11 plus 1. This will be our nth term. Okay, we know A and D, so we can easily calculate our nth term, right? But we need to know the total numbers. And in second solution, we can consider our series from like this one, and we can find the 11th term. Okay, so let's go to from this way. A is minus 62. Let's suppose our AP start from here. Okay, in the reverse direction. So the difference will be D will be positive. Okay, plus 3. because here we are decreasing the 3, and so which implies that here we are in the reverse direction we are increasing by 3. Okay, now we need to find the a11th term, which is a plus 11 minus 1 into d, which is a plus 10d, and which is a is minus 62 plus 10 into 3, which is 30, minus 62 plus 30, and this will be minus 32. Hence this is the solution. So solution, the 11th term from the last, right, we taking the series APC in the reverse direction, and the last term is minus 32. Okay guys, now come to the next topic, sum of the n terms of an AP. Okay, so we will be deriving the formula how to calculate the sum of the n terms. Okay, now let's suppose our AP is this one, a plus d, a plus 2d, like that, and it will be a plus n minus 1 into d. So this is our first term, this is our second term, okay, and this is our third term, and this is our n term. Okay, now guys, you see, for example, sum is s. Okay, s is equal to a plus d plus a plus 2d plus this one a plus n minus 1 into d. Let's suppose s sum is s. Okay, now reverse direction, take it number. Okay, like let's first a plus n minus 1 d, put the AP in the reverse direction. Okay, reverse d, like that, and it will be a plus 2d plus a plus d plus a. Okay, now add equation. This is our equation 1 and this is our equation 2. Equation 1 plus equation 2. Now add this one, this will be 2s. You see, now see this one, this is a plus n1 minus 1 d, it will be a plus a, which is 2a. Okay, in every term we will be see there is a a. Okay, a here, okay, and here you can see a here and a here. Okay, so it will be a always add, right, 2a. And what about happen with n d values? So you see there is no d here, it will be n minus 1 d. Okay, like that. Okay, now see here this one. Okay, a plus d. Okay, and here it will be a plus, let's suppose take one more previous term, n minus 1 2d. With this one, a will always 2a. Okay, and this n minus 2 and this 1d only, n minus 2d, and here is a 1d. Okay, and here for the last term we have 2a plus n minus 1d, and there is no d here. Okay, now see this relationship with this one. Okay, you can see n minus 2d and 1d. So if you solve it, it will be nd minus 2d plus 1d. So it will be minus 1d, right? D common, n minus 1. Okay, 2a plus n minus 1. Same here, take 2a, n minus 1 d, right? So you can say this term is always same. This term is always same, right? So take this common here. So you can see 2a is always same. So you can say and this 2a come n times because we have the n numbers. Okay, so n times we have this one. This is 2a plus n minus 1d, n minus 1 into d. Okay, so this 2a plus n minus 1d comes n times. So that's why you multiply by n. Now 2s. Okay, now what is s? Sum. Sum will be n by 2, 2a plus n minus 1 into d. Okay, so we easily get this formula, right? S. What is s? S is the sum of the n terms. This is what we need to derive here. Okay, so this is solved. Sum is equal to n by 2 in bracket 2a plus n minus 1d. Okay, so this is the formula to calculate the sum of the n terms. Let's come with some examples so that you can understand better. Okay guys, now we just derive the formula. Okay, the sum of the n terms will be n by 2 twice of a plus n minus 1 into d. Okay, and we also know the last term. For example, an is the last term. Okay, this will be a plus n minus 1 into d. For example, there is an AP of n terms, so last term will be a plus n minus 1 d. Okay, now you observe in this sum formula, sum is equal to n by 2. If you put this 2a as a plus n minus 1 d. Okay, now what is this? A plus n minus 1 d. This is our last term. Okay, and a is our first term. This is our first term and this is our last term, right? So it is just sum of first term and last term. So sum we can also write n by 2 a, which is first term, n plus a n, which is our last term. So this is also the formula. If we know the first term and last term, we can easily find the sum of the AP numbers. Okay, so for example, A, B and C are in AP. For example, they are in AP. Okay, now what is C? Value of B? B will be A plus C by 2. How it is 2? Because you can see, right, this for example, take the difference B minus A. Okay, this is the common difference and this is also equal to C minus B. Now B is equal to A plus C. Okay, B is equal to A plus C by 2. Okay, this is one of the properties if three numbers are in AP. Okay guys, now let's understand with some more examples. Okay, the sum, for example, this is an AP and we need to find the sum of first 22 terms. Okay, now see, A is 8 first term and the difference is 3 minus 8, which will be minus 5. Minus 2 minus 3 will be minus 5. Okay, so difference is minus 5. A is 8. Okay, the formula of S, right, formula of the first 20 term will be A n by 2 2a plus n minus 1 into d. Okay, and we know, right, 22, so it will be 22 by 2 twice of 8 plus n minus 1, which is 22 by 21 into d, which is minus 5. Okay, if you solve it further, it will be 16 minus, okay, is equal to 11 of 105 minus 16. Okay, it will be, right, okay. So sum of the first 22 term is minus 17. You can see, right, this series will go in negative. The difference is minus 5, right? It will go in some negative. That's why the sum is minus 979, because lots of the number are in negative. Okay guys, now we have some generic AP. Okay, so here we know, though the nth term will be 3 plus twice of n, and we need to find what is the 24th sum of the 24 number, initial 24 numbers. Okay, now you can see, right, an is equal to 3 plus 2n. So if you put n is equal to 1, you will be get 3 plus 2 1, which will be 5. A2 you will be get 3 plus twice of 2, which will be 7. A3 you will be get 3 plus twice of 3, which will be 9. Okay, now the difference is 2. Here the difference is 2. Okay, now A is 2 and difference is 2. A is 5. Difference is 2. Okay, now we need to find the sum of S24 terms, which is equal to n by 2 twice of A plus n minus 1 into d. N is 24 by 2 will be 24 by 2. Let's keep it here for now. 2 into 5 plus n minus 1, which is 23, and d is 2. Okay, now divide this by 2. 12, 10 plus 46, this is 10, right? 12 will be 46, 56 into 56. So this is the sum. You can even multiply 56, 12, Okay, the sum of the starting 24 number is 672. Okay guys, with this we have covered our complete agenda of the arithmetic progression. We have completed all the points here which is mentioned. What is arithmetic progression, what are the AP properties, nth term, sum of the n term, sum using the first term and last term, and some real world problems, how AP is helping to solve the real world problems. Okay, so in our next video we will be coming with the practice set of this arithmetic progression. So we covered all the questions that are more important with the exam perspective, so we will be covering in our next video. So if you have any doubt in this video in understanding any concept of the AP, then please comment here. I will be solve those, I will clear that doubt in our next video, or maybe I will comment on those your doubts. Okay, thank you guys. Please like and subscribe this video. Thank you for watching.